the lines R1, 2, 3, 3 plus lambda minus 3, minus 2, minus 3, and R2, 3, minus 2, 4 plus mu 7, minus 1, 7 intersect at the point P. Find A, the coordinates of the point P, and B, the acute angle between the two lines. Right, so what we need to do is find where these two lines intersect. And if we just look at this graphically for 1 minute, so here we have it graphically, and I'll attach this applet to the video. You can see somewhere down over here somewhere, these two lines will actually intersect. You can see it from this angle here, and later we'll go back to that and try to find out. And we should also realise as well, when we're finding an angle, there's two angles. There's this one here which is acute, or this one here which is obtuse. Okay, so just be wary of that. Okay, so we've got these two lines and we now have to find where they intersect. So let's go back to this. So where they intersect, at the point of intersection, this line will be equal to this line. So 2, 3, 3 plus lambda minus 3 minus 2 minus 3 will be equal to 3 minus 2, 4 plus mu 7 minus 1 and 7. So the object here is to find the value of lambda and mu where these lines intersect. So what you do, you consider the x and the y, find lambda and mu using simultaneous equations, and then check in the third one. If it's consistent with the third one, then the lines definitely intersect. If they don't intersect, the last line will be inconsistent. So for the x component, we're going to have 2 minus 3 lambda is equal to 3 plus 7 mu. For the y component, we're going to have that 3 minus 2 lambda is equal to minus 2 minus mu. Now, rearranging this, so we're going to be very careful here, we've got lots of negative signs. We've got minus 3 lambda, taking this over here, we're going to have minus 7 mu, and taking the 2 over here, we're going to have 1, 3 take away 2. And then repeating it for the other line, we're going to have minus 2 lambda, plus mu, sorry, and taking the 3 over here, we're going to have minus 5. So we've got two simultaneous equations here. Now, we should also write down the z ones at this point. So we've got 3 minus 3 lambda is equal to 4 plus 7 mu. I've written that in a different colour because we're going to use that for a different reason. So now working with these two equations, solving them simultaneously, so we'll label 1 and 2. So keep the first one as the same, minus 3 lambda minus 7 mu is equal to 1, and then we're going to multiply the second one by 7. So 7 times minus 2 is minus 14 lambda plus 7 mu, and it's equal to minus 35. Take great care in doing that bit, particularly when there's a lot of minus signs. Now the signs here are different, so we will add. So minus 3 lambda minus 14 lambda gives me minus 17 lambda. Minus 7 mu plus 7 mu is nothing, that's why we did it. And 1 minus 35 gives me minus 34. Dividing by minus 17 will give that lambda is equal to 2. Substitute that into either 1 or 2, so we'll go substitute into 1. So we get minus 3 times 2, minus 3 times lambda, which is 2, minus 7 mu is equal to 1. So we get minus 6 minus 7 mu is equal to 1. Taking the 6 over here, we're going to have minus 7 mu is equal to 7. Dividing by minus 7, we're going to get that mu is minus 1. Now, if we just write those two equations out again, what we need to do is just check that it works for the z component, which we wrote out before. So z component is 3 minus 3 lambda, and this one is 4 plus 7 mu. So we check them out separately. So the left hand side says 3 minus 3 times lambda. Lambda's 2, so that becomes 3 take away 6, and we get an answer of minus 3. We check the right hand side, we get 4 plus 7 times minus 1, which is 4 take away 7, we get minus 3. We've got the same thing, therefore these lines definitely intersect. Although we were told that in the question, we've actually shown it as well. They're consistent. So we also know that the z coordinate where they intersect is minus 3. To find the x coordinate, we just take one of this, we'll take lambdas 2 and put it into the x component, which is 2 minus 3 lambda, so 2 minus 3 times 2, which is 2 minus 6, which is minus 4. The y coordinate, we're going to do 3 minus 2 lambda, so 3 minus 2 times lambda, which is 2, 3 take away 4, which gives minus 1. Therefore, the lines intersect at the point minus 4, minus 1, minus 3. So we go back to this diagram here, and if we click on this point here, we'll get the coordinates there, minus 4, minus 1, minus 3. Okay, to find the angle, okay, we need to take the angle. What we're going to remember, the vector equation line, this is a point on the line, and this is a vector parallel to the line. Okay, so to find the angle, we need to find the angle between these two vectors, which are called the directional vectors of the lines. So consider the directional vectors of the lines. We're going to label this one U and this one V. Okay, and let the alpha be the angle between the lines. Cos of alpha will be U dot V divided by the magnitude of U times the magnitude of V from the scalar product idea. The cos alpha will be, so we're only considering these, minus 3 times 7 plus minus 2 times minus 1, so be very careful with the minus signs here, and minus 3 times 7 divided by the magnitude of the first one, so the square root of minus 3 squared, and again make sure you substitute using brackets, plus minus 2 squared plus minus 3 squared, the square root of 7 squared plus minus 1 squared plus 7 squared. So we're going to get minus 21 plus 2 minus 21 divided by the square root of 9 plus 4 plus 9 divided by the square root of 49 plus 1 plus 49. And we're going to get minus 40 divided by the square root of 22 square root of 99. Alpha will be cos to the minus 1 of minus 40 over the square root of 22 times 99. Now you need to do this on your calculator, so you either need to have a normal calculator or a GDC, depending on the course that you're doing. So for those who've got GDC, we'll go to calculation mode. Now my calculator is actually in radian mode, it doesn't matter. Trig cos to the minus 1 minus 40 divided by brackets square root of 22 with the arrow key and then another square root sign, 99, and move it over here and we get an answer in radians. To change that into degrees with this calculator, you go to the catalogue, press DDD, and you'll get 148.999 degrees. That's the obtuse angle. We want the acute angle, so to find the other one we do 180 minus my answer, so it's control minus, which will give, oops, sorry, and the mistake is here, I need to put 180 degrees, so pi 180 degrees, sorry. For some reason didn't like that, so we'll just put right down the obtuse one, and then we require the acute angle, which is going to be 180 minus 148.99 is equal to 31.0 degrees. Okay, if we go to our GeoGebra applet, which is here, okay, and we press this one here, we can get the angle and we can look at it from different viewpoints. There's the angle that we want, but just move that away a little bit, we can see the angle there. Okay, we can see that's the acute angle, and the one that the scalar product gave me was this one, which was the obtuse one. Okay, if you want to watch this in 3D, you can do by clicking this one and clicking this one, and then going for the glasses and putting your glasses on, you'll see the whole thing in 3D. Okay, but you do need red cyan glasses for that to work. Okay, so this applet I will put on to the notes of this video for you to try for yourselves. Okay, I hope you understood, and we thank you very much for watching.